Ever wondered how scientists calculate total rocket distance, even when its speed is constantly changing? Today, we'll unlock finding the area under a graph, its calculus connection, and introduce Riemann sums. We'll start with simple shapes, then tackle tricky curves, seeing how brilliant math finds exact answers. For rectangles or triangles, area is straightforward. Length times width, or 1/2 base times height. A car at 60 miles per hour for 2 hours is a rectangle on a graph. Its area, 120 miles, equals total distance. But what if the speed isn't constant? What if the graph is a curve, showing acceleration or deceleration? Simple formulas won't work here. The area under this curve isn't a neat rectangle or triangle. So, how do we find this elusive area? Here's a clever trick. We approximate the curve's area by drawing many small rectangles underneath it. Like slicing a loaf of bread. Divide the total interval into smaller segments. Over each segment, draw a rectangle whose height touches the curve. Sum their areas. Notice how summing these rectangle areas gets much closer to the actual area under the curve as they become thinner. The magic happens with infinite, incredibly thin rectangles. As their width approaches zero, their sum exactly matches the curve's area. This brilliant idea of summing infinitely many tiny parts is the heart of integral calculus. It shifts us from approximation to precision. Beyond distance from velocity, finding area under a graph helps engineers calculate the total work done by a varying force. Economists use it to find total profit from a marginal profit function. It's all about accumulating changes over time. So, the area under a graph isn't just a number, it represents the total accumulation of a quantity. Remember, approximating with Riemann sums, and then taking the limit as rectangles become infinitesimally thin, leads us to the exact area. This powerful technique is the core idea behind integral calculus. From rockets to rivers, it solves real-world problems with incredible accuracy.